So now let's look at the quanta of the B quark and the quanta of its decay products. We'll look first at the electric charge, spin, and the weak charge. So we have electric charge up now, and we can look, and we can see that the electric charge on the generic D is minus 1/3 with 0 charges on the anti-V's. But, and we can see that the boson 0 is making no contribution to the electric charge, as well as the flavored boson 0 as well as the unflavored prime are making no contribution to the electric charge. And if we look, we'll see that the opposite is true for the anti-B as it should be. But then if we look at the C quark, we'll see that though we have again the generic D quark contributing minus 1/3, we now have a boson plus, a scalar boson plus, contributing a +1, transforming the D quark into a C quark and giving it the appropriate charge of +2/3. And then this antiparticle pair contributing nothing to them. And if we look here to the significant portion of the W minus, we have these two T anti-T pairs contributing no electric charge, but we have the boson minus contributing a -1, and then these particle pairs contributing 0. And so now let's look at the spin. And so we see, we start with the spin of 1/2, a right-handed spin D quark, generic D quark, because the two anti-V's have opposite spin, and therefore all the spin is contributed by the anti-T. And we see the scalar boson 0 contributes no spin, as well as the neutral flavored boson 0. And of course, the opposite will be true for the anti-B. Now let's look at the C quark. And so we see that there's been a change from this anti-T to different anti-T. And this anti-T is carrying a left hand or -1/2 spin, so that now the generic D part of the composition carries a left-handed spin of -1/2. And again, the boson plus and the boson 0 are scalar, and they contribute nothing to the spin. And we see here we have these two this particle-antiparticle pair, which have a spin 1, and they're giving spin 1 to the boson minus W quark that's been emitted. And if we look, we'll see that we have the opposite for the composition of the anti-B. Now, let's look at the associated weak charges. And so since we started off here with a generic D quark with a spin 1/2, a right-handed spin, then the weak charge should be 0. And we can see that since we have a 1/6 plus 1/6 is 1/3, and a minus 1/3, that gives us a weak charge of 0. And the scalar bosons here contributing nothing to the weak charge. So we have the appropriate recharge according to the standard model for the B quark. And we'll see that the opposite will be true here. And since this is a left-handed antiparticle, we see that there also is a 0 weak charge. Now, we shifted the spin on the generic D quark, and so we can see the weak charge has changed. And so now we have a minus 1/3, a minus 1/3, and a plus 1/6, which will give us a minus 1/2 for the weak charge. And we'll see that, but that's correct for the D quark, a left-handed D quark. But then if we look and see the boson plus has a weak charge of 2/3 plus 1/3, which is 1, and so it will change the weak charge to plus 1/3 plus 1/2, which is what it needs to be for a left-handed C quark. So the composition, the quanta of the composition is consistent with the standard model, and we'll see the boson 0 being a particle-antiparticle pair contributes nothing to the weak force. And we can look at the W, and we will see that we have a minus 1 on this port, the scalar port, and we have a plus 1/2. So that gives us a minus 1/2 on the W minus boson, spin 1 W minus boson. Okay, and so there we see that the electric charge, the spin, and the associated weak charge give us an accounting which is consistent with the standard model.